Oh, a long division. Now this time for polynomials. Okay, so let's get into it. So here's an example that I present to you. And typically when we want to do long division, you will notice that you will have your order or the degree of the polynomial in the numerator is going to be typically higher or equal to the degree or the order of the denominator. So in this case, the order of the numerator is actually 3, and then the denominator, the order, the degree is 1. Now, if you forgot about order or degree, I'll put up a link up above there for polynomials. You can check that out. So in this case, we can actually divide the denominator into the numerator. Now, it gives us headaches because it's not always very simple. So let's do a little bit of a deja vu. So instead of jumping straight into this long division, I will try to kind of recall if you had just regular numbers, forget polynomials. So let's say we had, say, 108, and then we were trying to divide this 108 by 7. And when we're doing this division, so in this case, we're going to get some kind of a remainder. Sometimes we know that the denominator is going to go into the numerator exactly, right? So which means that it's a factor of the numerator. But that's not always the case. Most of the time it's not. So if you had to do long division for this, well, what we would do is we would try, at least I set this up in this particular way, and then I just say, all right, so how many times does 7 go into this 108? And then we can go ahead and we proceed. So, we kind of notice that, all right, well, it can't really go into 1, but it can go into 10. Well, how many times? It's going to go into 10 just one time. And then 1 times 7 is going to give us 7. And then we go ahead, we subtract. I'm going to get 3, bring down this 8. And then I'm going to ask the same question. Okay, so now how many times does 7 go into 38? And then, you will say that, oh, okay, well, it goes about 5 times. So you're going to get 35 divided by minus this, and then it's going to get 3, and this becomes your remainder, right? Now, this hopefully is still in your mind, kind of all the way back from elementary school in some way. But of course, we're going to be dealing with polynomials. But the concept is going to be the same. So I want you to keep this in mind, so how many times does something go into something else? Now, these, I don't typically use them, but I know that, for instance, so this 7, so when you're dividing by this, we typically call that the divisor. And then this particular 108 right here, so this is your dividend, or sometimes I call it dividend. Okay, so that's goes in the numerator right here. And then your result, so this result right here is basically your quotient, and that is your remainder. So, keep that in mind because sometimes, if your teachers are working on this, they might do that. So again, if you're walking yourself through this, that's the divisor. This one right here is the dividend. That's the quotient, that's the answer. And then this is your remainder that you have. So let's now try the same process of this long division for these polynomials that we will have. And I'm going to take this one kind of as my first thing, and then I'll walk you through what we should do. And in fact, this is one of my first examples right here, and then I have some other examples to show you. And hopefully by the end, you can pause the video and then try these on your own. So let's go back here. So I want to just show you what we do. So the first thing that I always think about is, okay, let's write all of these things out just as we would in our division if it was just regular integers or regular numbers that we would have right here. So I like to write, so I'm going to write my x plus 2 right here. And then this is going to be asking me, all right, so how many times will this go into the numerator? Now, the interesting part is, so our numerator, so this 3x cubed, now notice that it doesn't have an x squared term, but I do like to put it in. So Whenever there's a term that's missing from the polynomial, I like to put it in there just to remind myself that it's there. I'm going to put the coefficient or the coefficient in front of it as 0, because 0 times x squared is going to get rid of it. And then I'm going to put x and then minus 10. So I'm writing this a little bit differently than it is written out as you had it originally. And now let me maybe get rid of this because I think we don't need it. So I'll delete that, and now we can get started. So what is my next step? Okay, so I fill out, so don't forget these. Now the question is, because I'm not just dealing with numbers as I did before, so in terms of saying x plus 2, well, how many times does that go into, into what, right? Might be your question as you're doing this. Well, so first thing is, okay, what is the order of the numerator? Well, the order of the numerator, we said, was 3, okay, because that is the highest term that we have within there, and that is of 3. Now, the denominator that we had, well, the highest order is 1, and it's coming from this right here. And if you remember your exponent laws, so if you had to divide, so for example, if you had this, and then you had that, the division would have been x squared, right? So because you're going to take the exponent values, so 3 minus 1 is going to give you 2, which means that our result, our quotient, should be of second order. And this is kind of important because it's going to tell you where to start to input your actual quotient. So what I mean by that is the following. So since our result will be of order 2, I'm not going to start writing my numbers right here. I'm going to start my numbers on the second order, okay, which is going to be above right there. And that is coming because of the fact that this is of second order. So now I'm going to fill that blue box just as I did with the regular long division. So in the regular long division, I just filled it in with a number because I just wanted to see how many times it goes into it. So how do I decide what this is? Well, it turns out that it's actually not that terrible to think about this. So what you look at is you want to get rid of this particular term entirely. And to get rid of this term, okay, you want to ask yourself, what would you have to multiply this just your leading x by to get rid of that 3x cubed? So you have to match it. Well, so the first thing in terms of matching it, well, this is of third order, this is of first order. So to get it to the third order, I will have to multiply it by x squared, right? Meaning, if I take x right here, multiply it by x squared, I'm going to get x cubed. But this is not going to get rid of the 3x squared. So I have to put a number in front right here to still cancel that 3. Well, the number that I'm going to put in front is whatever the coefficient that I have of my x. Well, the coefficient here is 1. So what should I multiply 1 by to get 3? Well, that's going to be multiplying it by 3. So 3 times 1 is going to be 3. So I am literally now taking, I have 3x squared, and I am going to multiply it by x plus 2, just as I did in my long division with numbers. So if I do that, if I multiply this by that, I'm going to get 3x cubed, which is exactly what we wanted because we wanted to get rid of the 3x cubed there. But then, of course, it still has to multiply the second term, and that's going to give me plus 6x squared. So let me remove this right here and put it in here. So this is going to be plus 6x squared. And that is just the multiplication of this times x plus 2. And now, so just like in your long division, so what we will do is, okay, so I'm going to remove this right here. And I want to be able to now subtract this to see what is left over, what my remainder is. Well, this is going to be gone, right? So 3x squared minus 3x squared is gone, which is what I wanted. And now I have 0x squared minus 6x squared, which is going to give me minus 6x squared remaining. And the question is, remember, in long division, we would bring down what is next, right? Okay, so that we can continue this process. So in this case, what we will do is we're going to bring down our plus x right here. And now we're going to play the game again. So we're going to say, all right, well, we're done with the first one. Okay, now, maybe I shouldn't, I should maybe duplicate this. Now, okay, I'm going to ask, okay, so what should I put into this box now? And I'm going to get, now I can get rid of that. All right, so in order to now fill in that new blue box that I put in, I'm going to try to get rid of this negative 6x squared. So what do I do? What should I multiply it by? So again, well, I'm going to multiply it. So since I have an x here, so I'm going to multiply it by some x, right? So x times x gives me x squared. So I'm, one step down. So that's what I wanted. Now again, so the number that I fill in here, so in front of it, I'm going to get rid of the box now. I'm going to put in here negative 6. So now negative 6 times, and it's going to be multiplying this entire x plus 2. So negative 6 times 1 is going to be negative 6. And then negative, okay, so now what I have is this. I want to have negative 6x times x plus 2. And I'm filling it into here. So this is the multiplication. That's the negative 6x squared. And then I have to multiply this, which is going to give me negative 12x. So that's how that comes about. Now again, so I'm going to subtract these. Well, this is going to be gone. So that cancels off. Now what's left, okay, is my x and then negative and then this negative, so that's plus. So that's going to give me plus 13x. That's what's left over. And again, just like in long division, so I'm going to bring this down right here. So that's going to be minus 10. And now, as you can see, you're going to be playing the game again for the last time. So I have now my last item to fill in is, well, I need to get rid of, I'm going to try to get rid of the 13x that I see there, okay, by multiplying it by this. So what should I put in there? Well, I already have an x, so I don't have to put an x on top there. So notice what I'm going to do is I'm going to just put plus 13. Because this 13 now times x plus 2. So if I distribute this inside here, I'm going to get 13x plus 26. So that's exactly what I fill in right here. And then now subtracting. So that cancels this off, and then it's going to give me negative 36, which is my remainder. I have no more terms to drop here, so I am finished, and this becomes my remainder. So what the answer is, now that I have, so my answer, so this equals to my, so here's my, my quotient right here. So let me copy this, let me paste it. So that's how many times x plus 2 goes into the numerator of 3x cubed plus x minus 10. But you also have a remainder. So this remainder right here, so this is going to be, so that's my remainder. So it's going to be minus 36. But that remainder still is over, okay, your x plus 2. And that shouldn't surprise you, because if you wanted to convert, so if you remember, we had, okay, so I erased it there, but we had 108 over 7. This is really just a fraction. right? And then we wanted to see how many times does it go in. And then we had a remainder, and we would always put the remainder over 7 if we wanted to turn it into a mixed number. And that's exactly what we're doing right here. So that's your first example. Tricky, right? Especially if you're looking at it for the first time. So let us take a look, okay, at some other examples. And hopefully slowly you're going to get a chance to see this. Okay, and you can fast forward to whichever example that you want. All right, I have it time-stamped in this video. So I'm going to avoid this for the moment. Okay, I'm going to first actually create a separate example here, which is going to be similar to the one that I just did. So this one that we did is done. That would have been my answer. Now, if you want to check for yourself if that's correct, you can always bring it back, right? So since this was your result, you can always multiply it by this to put it under the same denominator. And if you expand that, and then you're going to have this minus 36, you will notice that this is exactly what you get back in there. Let's try another example. So in this example, so I'm going to make it up as we're going through. So let's say I have 2x squared plus 10x minus 3 divided by, and let's say this is x minus 1. So now we want to go ahead and do this long division. So first thing that I check is, all right, this is of second degree or second order, and this is of first degree. So that means 2 minus 1, okay, my quotient is going to be of degree 1. So now let's proceed. So I write it out, so I have x minus 1. Notice I do have all coefficients, so I don't have to put in any 0 coefficients in here. So this is going to be 2x squared plus 10x minus 3. And let's begin. So where do I start? I start of degree 1. So I'm going to start right here. Okay, that's where I'm going to start filling in my numbers. So I want to be able to cancel off this 2x squared right here. So how do I do that? So first thing that I do is, all right, so I take a look at this. I know that I'm going to have an x. Okay, so here's my x, because x times x is going to be x squared. And now I'm going to have to put in a 2 in front of it, because 2 times the 1, right? So I'm taking this and now I'm multiplying it by that. So that's going to give me 2x squared, so that's this term, and then 2x, and then it's multiplied by this 1, which is going to be given to me as minus 2x. So that's what I have right here, and now I subtract. So my 2x squared is gone, so that's canceled. And now 10x, now minus and a negative right here, so that's going to be plus. So this is going to turn into plus 12x, and I'm going to bring down my negative 3. All right, so that's what follows. Okay, so once I have this, now I'm going to move over, and I want to be able to, again, so cancel off this 12x in front. So that's 12x. So now how should I do it? Well, it's going to be, so times, I guess, plus 12. Okay, so 12 times this x minus 1, it's going to give me, so 12x, and then minus 12. That's right here. So that's coming from 12 times x minus 1. And now this subtraction, so this will cancel off right there. And then I get negative 3. So I have negative 3. Okay, well, these double negatives give me a positive. So that's going to give me a 9. I have no more terms to drop down in this long division. So I am finished. So my answer to this is 2x plus 12, and then plus my remainder of 9 And that remainder always goes over your divisor, which is x minus 1, okay, your denominator in this case. All right, so that's what you have there. Now, you can, as I said before, you can check, okay, did I do this correctly? Well, in order to check that, so I'm going to do this for this example, and you can do it for any others, okay, then I would have to find a common denominator, which means I would have to do x minus 1 multiplied by this. Okay, so here's my x minus 1. Now I'm putting this over x minus 1. And now distributing this across, so I'm going to have to distribute this across first, okay, on top there, which is going to give me 2x cubed plus 12x. Now next, you're going to distribute this across, which is going to give you minus 2x minus 12. All right, so that's in the numerator. It's going to be plus 9. Now notice the denominator is the same, so I can extend this and put all of it over x minus 1. And now we simplify by collecting like terms. And that gives me 2x cubed. Now 12x minus 2x is plus 10x. And negative 12 plus 9 is going to give me negative 3 divided by x minus 1. And is that what we started? And that's exactly what we started. 2x squared plus 10x minus 3 over x minus 1, right? So that's the check if we did the long division in the correct form. So that's another example for you. Now, both of these examples in our denominator was of order 1. Now, it's not always over and having an order of 1. Now, sometimes your teachers might be mean, okay, and give you, order 2 polynomial at the denominator, sometimes even order 3. So how do we tackle those? So let's take a look. So here is a very interesting example. So I'm going to take this one, and I'm just going to show you what can happen and what to watch out for. So there it is. And now how are we going to do this long division? Because it's not as pretty. So first off, notice that this right here is missing a lot of terms. And what I said is I would encourage you to put in the 0 terms as well, just so that you know exactly, okay, all the orders and you have them lined up. What I mean by that is the following. So I'm going to rewrite this. So 2x to the 4. There is no x cubed term, so I put 0x cubed. Plus, now there is an x squared term. There is no x term at all, so I'll put 0x, and then I'll put 0, okay? This now gives me the polynomial with all of them, so x to the 4th, x cubed, x squared, x, okay, and then just the constant. And now, so if I want, so let me correct this, let me put this a little bit nicer. So now I'm going to do the division. And then the division, so here is my divisor right here. Now this one has all its terms. So x squared plus 3x minus 1. If it didn't have, let's say if it was x squared minus 1, then what I would put is x squared plus 0x minus 1. All right, so don't forget that. And that just reminds you that, that it is, what are all the different terms of the polynomials that you should carry. All right, so that's definitely this is going to be a little bit more painful than the previous ones. So first question, where do I start filling in the numbers? So I have this is of order 4, this is of order 2. So 4, 2, right? Okay, so 4 minus 2, okay, gives me that my quotient should be of the second order. Well, my second order is right here. So I'm going to start writing my numbers right there. That's where I will begin. All right, so what is my number? Well, in this case, okay, so my number that I want to match is, or I want to get rid of, is this 2x to the fourth. So how do I get rid of this 2x to the fourth? I'm going to try to multiply this x squared by something so that it gives me 2x to the 4. Well, first, I know that I'm going to have to multiply by x squared, because x squared times x squared is x to the 4. And then I know that my coefficient here has to be 2, because the coefficient right there is just a 1. So that now gives me, so I'm going to take this 2x squared, and I have to multiply it by this junk, okay, to get my answer. So one by one, I will multiply these through. So my first multiplication gives me 2x to the fourth. My second multiplication will give me plus 6x to the third. And then my last one is going to give me minus 2x squared. Now, I'm going to get rid of this. Okay. And something interesting is going to happen that I'll tell you. And that's because our divisor, so this right here, okay, has 3 terms. So in the subtraction, so notice this cancels. Now I have 0x cubed minus 6x cubed. That's why that was important for us, at least for me, the way that I like to set it up so that I see it. And then x squared minus negative 2x squared. So that's going to be plus 3x squared. That's what we get there. And now the question is, all right, so what do I drop, or how much do I drop? Well, so I'm going to drop this one right here. So it's going to be plus 0x. Okay, so from there, and now you might say, well, it's 0 times x, which isn't anything. That's true, so it won't really do much for us, but still keep it there. And you should always drop as many terms as you have. So in this case, for example, we have 1, 2, 3 terms here, and you have 1, 2, and 3 terms right there. So now, what do I do next? Well, the process is exactly the same as before. So now I want to be able to cancel off this negative 6x cubed. So what should I put next there? Well, so it's going to be, so negative, I guess, 6, and it's going to be x. Because if I take the negative 6x and I multiply it by the x squared, it will give me negative 6x cubed. Now I'm going to take the negative 6x, multiply it by 3x, and that's going to give me negative 18x squared that I have. And then finally, it's going to give me plus 6x. So now subtracting. So I'm going to do that. So this cancels off. That's gone. Now I'm going to get kind of funky numbers in here. So 3 and then the negative 18, which is subtracted. So this is going to be actually positive. This is 21x squared minus 6x. And again, so we're going to bring this one down again, right there. So that's going to be plus 0. And which means we have to do it one more time, right? And then finally we're going to run out, okay? That's why it was important to add these terms in there. Because if you didn't, you would think that you already finished right in the beginning, right? And you wouldn't have anything else to drop. So that's why I fill in these zeros in between to keep me honest and remember that I still have to continue until I finally get to the last constant term. So now, so what will I do here? So I'm going to try to put in one more. And that will be, so I have 21x squared. So this, I guess, is going to be plus 21. And so that's going to give me 21x squared. And then 21 times 3. And that's going to give me positive 60, I guess, 3x. And then minus 21. So divided by Now the subtraction, so this cancels. And I'm going to get, so this is going to be negative 69x and plus 21. And now you're finally finished. So this is your remainder. So your answer overall, okay, if I zoom out here, we'll change it. So your answer is going to be 2x squared minus 6x plus 21. So that's from your quotient right here. And then you have to add your remainder right there. I'm going to add it. Okay, so this is going to be, so I'm going to say plus, okay, and I'll keep it kind of like this, 69x plus 21 all over, and that is x squared plus 3x minus 1. So be careful, because I know that, so here you might wonder, why did he put plus, but here it's minus? Okay, so if you write it out, you have to be careful. So careful, don't write it like this. So 69x, okay, and then you'll say plus 21 all over x squared plus 3x minus 1. Because if you do that, then you've taken out the negative out of here and you made this positive, this 69 positive, but then you would have to change this sign as well. All right, so just to play it safe, I put a plus and then I left the remainder as it is, okay, right there. So hopefully that makes sense, or if you like, you can leave a comment below and I can try to explain it. So that's another example. This one was definitely much harder, and if you understood this one, you know, you can go back and try to replicate the solution on your own. So here is a final example that I have for you. I think, so hopefully, yeah, so this one's a little bit easier. So let's take a look. I'm going to copy this and see what happens. So paste it within here. So we have 2x cubed plus 10x minus 3, and then it's divided by x minus 1. So that's what we have there. All right, let's try it and see what it gives us. So again, so I'm going to write it out. So x minus 1, and let's write this nicely out. So 2x cubed. Notice there is no x squared term. So I'm going to leave it as 0x squared plus 10x minus 3. That's what we have there. And now let's get started. So this is x cubed, and it's x, so cubed and to the 1. So that means our result will be of second order right here. So that means we have to start writing numbers right there. So I will do that. And those numbers are, all right. So we want to get rid of the 2x cubed. So that means I'll put x squared and then 2. So 2x squared times this is going to give me, so this is 2x cubed, so that's perfect, minus 2x squared. All right, so that's subtraction. So that is gone. And now I'm going to get 2x squared left over here. Again, so here I have two terms. I'm going to drop one of these. Now we can continue. What does that give us? So the next one is, so it's positive, so it's going to be plus, I guess, 2x right there. So that gives me 2x squared minus 2x. It's another one. Subtract. This is gone. This is going to be 12x. Let's bring this one down. So minus 3. And now the last one, so it's going to be plus, I guess, plus 12. That's what we should have there. And so 12, so this is going to be 12x minus 12. Now subtract. So 12x is gone. And this is going to give us plus, I guess, plus 9. There we have it. So our total result is 2x squared plus 2x plus 12, and then plus our remainder. Now it is positive in this case. That's going to be it. So that's the long division that we had. All right, so those are, quite a few examples that you had. You can certainly try them and then see if you can try them on your own. Now, of course, you might run into some other ones that might give you some headaches, but I hope that this gives you a good introduction and a good idea on how to proceed with this long division for polynomials. Thanks for watching. See you in a future video. Okay? Bye.